Viel Spaß.
Okay. Thank you very much. Thank you for coming here. I'm very excited to tell you something about the use case I'm working on right now. And this is the extraction of medical data from documents. I'm trying to give information or interesting information to all of you, so to managers, to techies, to everyone, so that everyone can, get something out of this topic. That's me. I'm Alex. I'm a senior data scientist here at Allianz. I've been working here since 5 years. I've experienced 7 years in data science. I worked as a consultant before, as a data science consultant. I studied business administration, and yes, I know that's not a technical degree I have, but within my master's degree, I started to, go to the data science or become one of the data science scientists, go into the data science world. And now with over 7 years of experience, I'm happy that I can show you today what I've built here for Allianz in our use case. I will now tell you what the business problem is, because we always come from the business problem first and then try to solve it with AI. And as you remember, one of the 5 Datageeks was a very good friend of mine, and that's Tom. And Tom is really cool, Tom is really chill, he's a very good friend of mine. But unfortunately, he wanted to come today, but he got hit by a car. And when he got hit by a car, he obviously had to go to the hospital where he is right now. I'm making fun, but yeah, that's the interesting part. So when he goes to the hospital, he meets a doctor. And this doctor, examines him, etc., etc. And the doctor writes a document or a documentation of what Tom has. So Tom has several diagnoses because he got hit by a car. But luckily, the car holder that hit Tom is insured at Allianz. Thank God, because now we are able to help him very efficiently, very fast, not only the car holder, because we have to help the car holder for sure, but we also want to help Tom, because Tom is now in the hospital and maybe he needs money, maybe he needs something else, etc., etc. And this is what the business problem is, because we have lots of information in the document that our claim handler now has to extract. Today, this process is very manual, it's very cumbersome, it's very annoying, it's very tiring. So this is a problem that we want to solve. How do we extract this information that is in the medical document very fast? And this medical information can be mapped to an international code. And this code is called ICD-10. What's ICD-10? ICD is the International Statistical Classification of Diseases and Related Health Problems. And this is the 10th revision. So there will also be an 11th revision, etc., etc. And what's an ICD-10 code in one sentence is just a mapping of a diagnosis. So, for example, we have an ICD-10 code, which is very common in our cases, which is the S13.4. And this is the sprain and strain of the cervical spine. This is this part of your body. And this is obviously a lot of the times when you got hit by a car, this hurts. How is this built up? Just very fast. It's built up out of a chapter. What's an injury? This is very relevant to us as an insurer. The category, injuries of the neck, and the subcategory, sprain and strain of the cervical spine. That's right here. So we remember, Tom is in the hospital right now. He got examined by a doctor. We have a document, and we have our claims management system. And this claims management system is obviously handled by a claim handler. And we have in this claims management system lots and lots and lots of documents, hundreds and thousands and millions of documents. And we have one claim, and this one claim has several documents. Now, I, as a data scientist, now want to get the relevant information that I need to get out of our claims management system, and that I get in a structured way by a JSON file. I also need relevant documents. So let's say I have one claim, and this claim can have 100 different documents, but I'm only interested in the relevant documents that I'm able to get from, a certain ID. I do now OCR on this relevant document. So not gonna go into much detail. OCR, I just get raw text out of my documents. And after I do OCR, I use my prompt, I use my large language model to understand actually the content of this document. And then I have either a direct extraction. So imagine if you have a document where the ICD-10 code is written already. That's the very easy way, because I just have to do copy-paste. But the interesting point is, what about if I have the diagnosis written down in my document and no ICD-10 code? I'm only interested in the ICD-10 code. I'm not that much interested in the diagnosis itself. So I need some indirect mapping, which will be the interesting part today. After I have everything that I need, I can build up my JSON again, I can fill it and send it back to the claims management system. And then the claim handler is has been helped by me, because this is much faster. This is, as you will see in a second, this works very well, depending on, obviously how the document is built up, etc. But we are actually helping here because we have a very efficient process here that is also scalable. How do we do this? Just from a very high perspective, we are in the cloud here. We use several AWS services. We use TextRect for OCR. We use AWS Bedrock, in particular Claude 3.5 Sonnet. We use an embedding model that I will tell you more in a second. We use FaceDB from Facebook, and we are serving our model via AWECS. So let's look at how a relevant document might look. This is a document that is very typical for us, and yes, I didn't choose the most complicated document we have, but we have much more complicated documents. We have documents that have 200 pages and are just written in handwriting. I know this is easier, but I wanted to show you today just, I didn't want to get lost in detail. Let's look at what we have here. We have a diagnosis, and this is, everyone who's worked with OCR already knows that in general, this extraction is comparably easy. We have even a table structure, which is very good. We could use the table option in TextRect, but we don't even need it because this is well structured anyways. But what I want to show you is we do have handwriting, and we do have doctor's handwriting, which, if any one of you knows, is very complicated. I know that this is yet readable, but sometimes we have the case that I cannot read it as a human, but TextRect can understand it, so that's pretty cool to see. We have several diagnoses here. It's not interesting what they are, but you can just see that Tom, hurt his head, and he has the cervical spine issue, and he got hit here, and he has something that is called a Hochrasanztrauma, which I had to look up. And the Hochrasanztrauma is when you got hit by a car which was driving very fast towards you, then you might have something like a Hochrasanztrauma. Very nice word. So let's check step 2. Let's look at the OCR and prompt. I'm not going to show you any prompts, because it's kind of our business thing here. But I'm showing you what the results of our TextRect can be. In our case, TextRect goes line by line, that's why the block type is line. In our case, we get a confidence per line or per, what we have here. And you can see that the first line of the document was extracted. You can also see that this is wrong. So that's the problem. What do? After prompting, we use our large language model now, Claude 3.5 Sonnet. We see that Claude 3.5 Sonnet is able to understand, because of my prompt, the diagnosis. So I'm feeding the model with, extract the diagnosis from the text you are given, and I can see that it actually understands, okay, this is, Tom got hit by a head. We have other information that I will tell you more in a second, but we have also the diagnose art, which is Hauptdiagnose. This is important for us because the model also understands what is a main diagnosis and what is a secondary diagnosis. I'm only interested in diagnoses that are related to the accident Tom had. I'm not interested in any, other diagnoses that the doctor just might have written down that were actually there before the accident. And I got a small reasoning, so blah, blah, blah. You can read it by yourself. Now the last step is the most interesting step. That's like the heart of this idea. As I said, we want now an indirect mapping. And the question is, why don't I just ask Sonnet what ICD-10 code is this diagnosis? That's very important for us. Because I have a very specific list of ICD-10 codes. That's like the official Weltgesundheitsorganisations list. That, first of all, is changing every year. That, second of all, is the list that is officially implemented in our claims system. So I cannot just ask a large language model, what diagnosis is this code, because the model can just tell me anything. So what do? I train another model. I need a mapping of the diagnosis to the code. And right now, there are 84,000 different ICD-10 codes. That, for us, sounds quite a lot, but for the model, it's actually handleable quite easily. And what do I need now? I need an embedding for my 84,000 ICD-10 codes. I'm doing this embedding with the Cohere model. What do I get? I get embedding vectors which are in a 1024-dimensional space. And at the end, I also want to add an index. Why do I do this? Because I want to be able to find my relevant vector very fast within these 84,000 vectors. That's why I need the Facebook artificial intelligence similarity search engine. And now I have vectors, and now I have an index for each of this vector. Let's look at a very concrete example. As you know, Tom got hit by a head. That's our string that we have. We embed this string to a 1024 dimensional vector, and we use the k-nearest neighbor algorithm to find the nearest neighbor. So, as you can see, we have a distance, which is very, very, very small, because it's sorted for the first one, and we have an index. That's what we got from the Facebook model. We have the ICD-10 code, which is S00.95, and the diagnosis mapped to the ICD-10 code is Kopfprellung. And now you see how similar these diagnoses actually are. So remember, we have 84,000 different ICD-10 codes, and we need to be able to map this to different diagnoses. And honestly, this is very easy to understand, Kopfprellung, but there's so very complicated diagnoses. I don't even understand any of them, but that's okay because I'm not a doctor. Let's look how we manage this. You remember what I showed you before. We have the Kopfprellung. We have actually the second diagnosis as the second word, and we have our Kopfprellung again. This is what you saw again. But then at the end of my JSON, I will also send the ICD code indirect mapping, and you get the S00.95, which was correct in this way. I can also show you the other ones. So the next one, and this is what I'm just looping through, right? I'm looking through the whole document. I'm looking up all the diagnoses, and now I'm mapping each diagnosis to an ICD-10 code. The next one is our favorite, oh, no, don't say favorite, our most common one, the S13.4, the injury of your spine. And we get now. And what I want to show you, which is interesting, I'm not only interested in the diagnosis itself. What about if I hit my knee? I also want to know if I hit my left knee or my right knee. That's important for us to know. So we added what's called Seitigkeit, so the side of the injury. This is also important. I mean, this is straightforward because it's not hard at all for a large language model. But what's interesting is the next one. I can also have diagnoses that were diagnosed before the accident. And then they got something which is called Zustand nach. This is actually what happened after the event. And this I also have to be able to understand. And you know, where you can see BER space Z space N, that's kind of, you know, wrong extracted, but still my model is able to understand that this is actually the Zustand nach. So Tom got this diagnosis after the accident has happened, as a result of the actual event. Now I want to give you some numbers how good this works, right? So this is actually already my last slide. So I'm trying to get a bit more into detail. When we do the evaluation of our use case, that we got some problems. So first of all, we ask ourselves, what's the ground truth? That's very hard to identify, because if I ask a doctor what's the correct ICD-10 code for a very specific diagnosis, if I ask 10 doctors, I will get 11 answers. And this is the very, very hard part, because ICD-10 codes leave space for interpretation. And every data scientist knows, if I have space for interpretation, how do I build up my ground truth? That's kind of very hard, right? What we did is, we had a sample of our results, or not of our results. Before we took our model, we had a sample, and we asked our corporate doctor for each diagnosis we had, what's the comparing ICD-10 code, knowing that we still have this space of interpretation. But I mean, somewhere we have to start. So obviously, when we talk about ground truth, our corporate doctor is always right. Second, we have our claim handler. That's also very interesting. So I show, let's say, a sample of 1,000. I show 1,000 diagnoses to a claim handler, to my, to the claim handler that I'm working with. We don't have every number filled here, but for example, the diagnosis, the claim handler now has to go through each of the 1,000 diagnoses and check what ICD-10 code would I choose. So in 77% of all diagnoses, he had the same diagnosis as the corporate doctor, which for me is a true. The interesting part is, direct ICD-10 code, you know, he's very good at finding the human, let's say, is very good at finding direct ICD-10 codes, because that's kind of straightforward, right? You have a document, you have the ICD-10 code written in it, that's kind of easy. But look at the number of the indirect ICD-10 codes. That's exactly what I mean. Because of the very vast space of interpretation, this is very hard to get. Let's look at our model. Just some ideas to the injured person. When the document comes in, we have to check whether this document is actually the document for Tom. Because we need to be very sure that this is the same person that we are talking about. Sometimes we have the issue that, you know, doctors just send us wrong documents, and now I have, you know, the document of Max Mustermann, but Max Mustermann is obviously not Tom, so I have to make sure that this is the right one. The diagnosis extraction works very well, so this is very good. The primary and secondary diagnosis, you remember, we have diagnoses that are directly compared or directly connected to the injury, to the accident. That's very good. We have the direct ICD-10 code mapping for 97%, and we have the indirect ICD-10 code mapping. So 68%, we would say, I mean, I made this yellow. So we are not at the end of our journey yet. But what's interesting, or what's important, is we always have to compare the model to the human precision, right? Or to the human accuracy. That's important. So we are better, like by over 25%. So that's a very good, for now, a very good increase, because you have to remember that for a claim handler, for a human, this whole process, finding indirect ICD-10 codes, reading through documents, this takes several minutes. And this, the model obviously finds this in several seconds. So this is a huge increase that we can increase our claim handling so we can actually faster help the car holder and faster help Tom, who's in the hospital. And this is actually it. I wanted to show you that we are also better at the diagnosis part, 94%. The thing that I'm working on right now, we are going live with this in September this year. The thing that I'm working on right now is the indirect ICD-10 code mapping. And what I'm trying to do right now is I'm trying to narrow down the ICD-10 code list of 84,000 ICD-10 codes only to relevant categories that are relevant for us. So for example, as you saw, we are in the capital of S here, which is injuries, which is very relevant for us. But there are also categories that are not relevant for us at all. So I'm working on this right now. You know, I'm trying to narrow down the list. So my similarity matrix is just not as huge as it is right now. And yeah, this is it. This is me again. If you found this cool, what I just said, if you found me cool, just hit me up. Get connected by me, have a talk with me, have a beer with me after this. I'm very open to answer questions, and the formal questions I can also answer right now. Thank you.
Thank you.